In this video, we're going to show that this sequence will be monotonically decreasing. So what you've got here is n factorial. So when n equals 3, it will generate this, and then when n equals 4, so it's 4 times 3 times 2 times 1 and so on. Well, this is n equals 5, 5 times 4 times 3, and so on. Just by glancing at this, you can tell that it's monotonically decreasing because remember 1 over x looks like this. 1 over x graph looks like this, and then as you can see that this thing here is getting bigger and bigger and bigger. So that means as n gets bigger and bigger, this bit here will get smaller and smaller and smaller. So this thing here, this thing here will just get smaller and smaller, and then you've got 1 adding a smaller and smaller amount each time. So that means it must decrease. So what you've got here is, this is your 1 here. Let's say this is 1 here, 1. So here you start with 1, and then first you add a big amount. So you start at 1, and then you add a big amount. So let's say it's here, and then the next term you start at 1, but then you add a smaller amount, and then you start at 1, add a smaller amount, and then you start at 1, add a smaller amount, and start at 1, add a smaller amount. You can see that it's decreasing. It's monotonically decreasing. So by just glancing at this, you can tell it's monotonically decreasing. But let's try and put this into writing. We are going to show that this sequence will be monotonically decreasing. So we're going to try and show that. So if we want to show that it's monotonically decreasing, we want to show that the next term is lower than the current term. We want to show that the next term is smaller than the current term. So we want to show the next term is smaller than smaller or equal to. But we want to show that the next term is smaller than the current term. So basically, we want to show this. This is our next term here, because if you look at our sequence, this is an here. Then if you want an plus 1, the next term, well, you would put n plus 1 into here. You would have this 1 over n plus 1 factorial. So basically, we want to show that the next term, is smaller than the current term. We want to show that this will be smaller than this. So we want to show, this is our next term here. We want to show the next term being smaller than the current term. Basically, we want to show this. We want to get to this stage here. So we're going to start with n is bigger than 0, because when it comes to sequences, you start at 1 and then you go all the way to infinity. So you can make this statement for our scenario. Our scenario being we are working with sequences. So it starts at 1 and then it goes to infinity. So we can say that n will be bigger than 0, because we are always in the positive realm. We don't really care about the negative. So n here will be bigger than 0. Let's start at this, and then slowly somehow get to this. And then once we can show that the next term is smaller than the current term, then you can see that it's monotonically decreasing. So start with this, add 1 equally to both sides, so that will then take you to here, and then from here times n factorial to both sides. So 1 times n factorial over here times n factorial. That will then give you this. Now, if you look at this here, it's like me giving you this 8. So this is n plus 1 here, and then 7 times 6 times 5 times 4 times 3 times 2 times 1. This thing here is really, this is your n here, n factorial. So this whole thing here is really n factorial. This thing here is really this, and your n plus 1 is this one term here. So you can simplify this as saying 8 factorial. So this thing here will simplify to this. Okay, so this thing here is the same as this. So now, hang on. Now from here take the reciprocal of both sides. So remember, when you take the reciprocal, let's say for because n is always positive, don't forget, because what we're dealing with sequences, so n will always be in the positive realm. But if you have 4, let's say 4 and 3, you can see that 4 is greater than 3. But if you take the reciprocal, 1 over 3, then this sign switches over like this. So it's not true when it's negative, but but we are not working in the negative realm. We are only working in the positive realm. So we only care about this being positive and this being positive. Well, when this is positive and this is positive, if you take the reciprocal, the sign, currently 4 is bigger than 3, the sign switch over. So here, from here, take the reciprocal of both sides, but remember to switch the sign over. So it's so this thing will be less than this thing here. So now once you're here, add 1 equally to both sides. That will then give you this, and then you can see here the next term. This is our next term, n plus 1. The next term will always be smaller than the current term. So this is our next term. This is our current term. You can see that an you can see that the next term will be smaller than the current term. So we've just shown that it's monotonically decreasing. Okay, so this sequence here is monotonically decreasing.